All right, so as I said, I want to go through talking about the shorthand, just so you can start seeing, oh, that's another way of doing it. Um, it. The way that having done a bunch of these chain rule problems before, the way that I do them now, the first thing to do, as we did last time, is to re-express this um, as cos of 2x cubed. And the outer function, the first thing that we've got going on is we've got something cubed. The next thing is we've got cos of x, and the third thing that we have is that innermost thing, 2x. So, f of x being something cubed, g of x being cos of something, and h of x being 2x. So the way that I think you want to eventually get to is f prime of x. The outermost thing is a power function. It's something cubed. So the first thing is, I don't want to do that in blue. The first thing is something cubed. So something cubed, the derivative of that is 3 times that something, well, the something being what's inside, squared. And that takes care of the something cubed. And then we want to do the next thing. So number 2, cos of 2x. Well, the derivative of cos is negative sine. So times negative sine of what's inside, 2x. So that takes care of the cos. And then the last thing that we want to do is the third thing, the 2x. So the derivative of that is 2. And we get the same thing as before, negative 6 times cos of 2x squared sine of 2x. But I think that's clearly a lot shorter. So let's look at another example of this shorthand. Um, you know, Once again, re-express this as 9 minus x squared. We've already done this kind of the long way. The shorthand way, you know, our outermost function is something to the 1/2, and our innermost function is this 9 minus x squared. So you work outside in. So the derivative, f prime of x, um, taking care of the first thing, the power to the 1/2, will be 1/2 my inside, and then that 1/2 minus 1 to the negative 1/2. And that takes care of a power of 1/2. And then we multiply that by the derivative of the inside, the derivative of the inside being negative 2x. That takes care of this. And then this is exactly what we had before, and we could go ahead and simplify it. And I think when you simplify it, you get negative x over the square root of 9 minus x squared. So this is a much quicker method, but I don't want you to start doing this until you get really comfortable with the chain rule, because the chain rule, there's a set process, and this is a little bit more flying by the seat of your pants. I don't understand that expression. Okay, two more things that I want to do is first use this idea of the chain rule to be able to find the derivative of ln x, so deriving a new function, and then we'll just have one challenge problem to finish it off. Okay, so to find this derivative of ln x, let's start off with a statement of e to the ln x. We know that e raised to the ln x, or e to the ln of anything, is just that anything. So e to the ln x is x. So if we took the derivative of both sides, let's do that. So the derivative of e to the ln x equals the derivative of x. So as long as we take the derivative of an equation, the derivatives will equal each other. So on the right-hand side, we know it. The derivative of e to the x, or sorry, the derivative, looking at the right side, the derivative of x is just 1. Just as a reminder, that's power of 1 with a coefficient of 1, so the 1 would drop down. The 1 would drop down and would be x to the 1 minus 1, 1 times x to the 0, just 1. On the left-hand side, we've got a composite function where f of x equals e to the x, g of x equals ln of x. And we know that the derivative of that is f prime of g of x times g prime of x. Well, the derivative of e to the x, we know is just e to the x. So f prime of g of x would be e to the ln x times g prime of x. Well, g prime of x is the derivative of ln x. So therefore, um, this, which I found right here, we have e to the ln x times the derivative of ln x equals 1. And if we simplify e to the ln x, we know that that's just x. So x times the derivative of ln x equals 1. And then solving for the derivative of ln x, we are able to get that the derivative of ln x equals 1 over x. A huge, very, very often used derivative. So add that to your bank of derivatives of functions that you can now derive. We now know that the derivative of ln x is 1 over x. Let's write that just on one huge page, and you're going to remember this. The derivative of ln x equals 1 over x. Cool. So let's finish with this problem. Um, we've got e to the sine of 1 over x. And I already did this to start off the video, thinking about this, taking the derivative layer by layer. But let's do it again. So, and I'm going to write it big. So we have e to the sine of 1 over x. So the outermost function is e to the x. The next function is sine. And then the innermost function is 1 over x. So the way that we find the derivative is we take the derivative of the outermost function. So the derivative of e to the x is e to the, and then whatever's left over. And so we just did the first one. And now we look at the second one. So we've got sine of 1 over x. So the derivative of sine is cosine of whatever's in the inside. And then, so that takes care of that. And then we take care of our third one. Well, derivative of times the derivative of 1 over x, it's quotient. So low d high minus high d low all over low squared. And when we simplify this, we get e to the sine of 1 over x times cosine of 1 over x. And then there's a minus sign from that, so minus all over x squared. Pretty cool. This will take some practice. It'll take some getting used to. So if you're feeling frightened, try not to think about that too much. Know that you'll figure this out eventually. It takes practice. It takes practice, practice, practice. But then when it clicks, it's very, very simple process. So now we're able to take derivatives of many things now. We can take the derivative of all the trig functions, of ln of x, of exponentials, of powers. We can take the derivatives of composite functions, product functions, quotient functions. We're expanding our ability to derive anything.